So the characteristics that make one substance different from another are called properties. So the properties of a substance. There are physical properties and there are chemical properties. A physical property is one that a substance displays without changing its composition. It's something that you can observe without destroying the substance. So gasoline has a distinctive odor. You can smell that without destroying the gasoline. Taste, color, appearance, melting point, density, many other properties are physical properties. So I can ascertain the color of this bin is white. That's a physical property. It doesn't require destroying the bin, right? You can taste your food. It doesn't destroy the food to identify the taste. Once you swallow it and it starts being digested, it's going to get destroyed, but just tasting it doesn't destroy it. A chemical property can only be displayed by changing the composition of the substance. So the smell of gasoline is one thing, the flammability of gasoline is another. To demonstrate that gasoline burns, you destroy the gasoline, right? And so that's a chemical property. Other things are corrosiveness, acidity, toxicity. So if something is going to rust, like a metal nail, an iron nail will rust. When we demonstrate that, the metal nail gets destroyed. If I want to find the mass of the nail, how much does it weigh? I put it on a balance. That doesn't destroy it. That's a physical property. So a chemical property, when you demonstrate it, destroys the substance, changes it into something else. So physical properties, the atomic or molecular composition doesn't change. So here we have water boiling. This can be tricky because you say, well, it's changing. It was a liquid and now it's a gas. But we have to zoom in and think about the particles. When water changes state from a liquid to a gas, the particles don't change, just the relationships between them. When we go from the solid state and it's time for class to be over and you go out that door, are you as an individual destroyed or combined with something else? No, you're you. You're just not so close to all these other people, right? So changing state is always a physical property, the melting point, the boiling point, the temperature at which that occurs. I already mentioned this, rusting. So here you have an iron nail. Iron rusts. We know that. So here's the iron atoms in the nail. Is this amorphous or crystalline? Crystalline, because it's nice and arranged. It's not all messy. So when this rusts, it gets changed. The iron atoms get separated and oxygen comes in here, and we observe on the outside that the rust is flaky, it's not as strong, it's a different color. And so this is a chemical property that iron will rust. In the process of observing or demonstrating this chemical property, the iron is changed into something else. Yes?
Why wouldn't the color change be a chemical property?
Why would it be?
Why would it not?
Okay, the change in color is usually a chemical change. Observing what color it is a physical property. Yeah. It's a very subtle but important distinction there. Determine whether each of these is a physical or chemical property. The explosiveness of hydrogen gas. Physical property, chemical property? Chemical. When that happens, when you demonstrate it, the hydrogen gas gets destroyed. It gets changed into something else. The bronze color of copper is physical. You can look at a copper penny and say, oh yeah, look, it's this color. That doesn't change the copper at all. The shiny appearance of silver, physical. The ability of dry ice to sublime, go directly from the solid to the gas state. That's physical. Well, what's going on there? It's a state change. When it changes state, physical is a physical property. It's going from solid to liquid, liquid to gas, solid to gas, any of those. It's just changing how close the particles are and whether they're moving relative to each other. It's not changing the particles themselves. Any questions?